Hi everybody, so in this video we're going to continue with Chapter 10, Differential Calculus 2, specifically with topic 10.2, the chain rule. So here we have table 10.1 and its functions that can be differentiated with and without the chain rule. So we are familiar with functions that we can differentiate without the chain rule directly. So we know that the derivative of cosine of x, for example, is going to be simply minus sine of x. We know how to do the derivative of a polynomial by using the power rule. So we know that this is the same as 6x plus 5. We know that the derivative of natural logarithm of x is going to be 1 over x. And in this final case, we can rewrite it as y equals 1/3 times x to the minus 2. And we know that the derivative of this would then be equal to minus 2/3 over x to the minus 3, which then we can rewrite as minus 2 over 3 times x cubed. So to the right we have functions that we would have to differentiate with the chain rule. So why with the chain rule? Well, the reason is that these functions are composite functions. So remember that a composite function is of the form f of g of x, where we have the function g of x inside f of x. So in this case, to the right, where we have y equals cosine of 2x, notice that we have an external function, which is cosine of x, that would be f of x, and then g of x would be 2 times x. For the next one, we would have square root of x as the external function, and the internal function would be 3x squared plus 5x. For this other example, we know that the external function would be natural logarithm of x, and then the internal function would be 1 minus 3x. And finally, the outside function of this here is simply 1 over x, the reciprocal, or x to the minus 1. And then the inside function, g of x, would be 3x squared plus x. In the next slide, you're going to see the rule for the derivative of a composite function, or also known as chain rule. So if you have f of g of x, the function, the derivative of that would equal the derivative of the outside function, but you leave the inside function intact. You see that g of x is intact. So it's going to be the derivative of the outside function with the inside function unchanged or intact, times, so there's a point here, times the derivative of g of x, which is the inside function. So you're going to see this in examples, and it's much easier to understand. So next we will work on example 10.4, and it says differentiate each function by applying the chain rule. Start by decomposing the composite function into the outside function and the inside function. So for letter A, it's the example that we were talking about before. We have y equals cosine of 2x. So then the derivative of this would be the derivative of the outside, which is going to be cosine of 2x. So that's going to be minus sine of 2x times the derivative of the inside function, which we said is this one here, right? 2x. So the derivative of 2x is this 2 times 2, and then we can rewrite this as minus 2 times sine of 2x. Notice that you cannot multiply this times this. A lot of people make that mistake, but this is part of the sine function, so it's separated from that 2 multiplying the sine. You have to do the sine function first before multiplying by 2. Let's look at letter B. So for B, we have that y is equal to the square root of 3x squared plus 5x. Recall that we can rewrite these with exponents. So this would be the same as saying 3x squared plus 5x to the power of 1/2. So if we do the derivative of this, we would do the derivative of the outside function first, which is all of it, right? So this would be 1/2 times, and leave the inside intact. So we write 3x squared plus 5x, keep that intact. And now we subtract 1 from the exponent. So this would be negative 1/2. But we also have to times it, the derivative of the inside function. So times 6x plus 5. And then this would be the derivative for b. So for c, we have y equals natural logarithm of 1 minus 3x. So the obvious external function here is natural logarithm of x. So we would write this as derivative of y will equal 1 over, and remember that we have to leave the inside intact, so we would write 1 over 1 minus 3x. Because remember that, again, the derivative of natural logarithm is 1 over x, and this times the derivative of the inside function, and this would be negative 3. Negative 3. So this can be rewritten as minus 3 over 1 minus 3x. And it's not uncommon that you're going to see this rewritten as 3 over 3x minus 1. Notice that if we change the signs in this, it would be the same as putting a negative in front, right? And then that cancels out the negative, and that's why you get this. So for D, we have 1 over 3x squared plus x. And we can simply rewrite this as 3x squared plus x to the minus 1. And then we can apply the chain rule to find the derivative. I forgot to say that this equals y. So the derivative of y would then be equal to, and we use the power rule for the outside, leaving the inside intact, right? So this would be negative 1 times 3x squared plus x, now to the minus 2, times the derivative of the inside, 6x plus 1, 6x plus 1, and then we can simply rewrite this as being equal to minus 6x plus 1 over 3x squared plus x squared. And we would stop there. Normally we don't expand these and anything like that. You would leave it in this exponential form. Sometimes you might even find it in this form. But you have to recognize that these are equal to each other. So next is example 10.5, and it says find the derivative of the function y equals 2x plus 3 cubed by letter A, expanding the binomial, and differentiating term by term. Okay, so that means doing the binomial expansion of y equals 2x plus 3 cubed. And maybe we can review a little bit of Pascal's triangle. Remember that Pascal's triangle goes like this. You have a sequence, it goes 1, then 1, 1, then always 1 outside, 2, 1. And then the one we need is the next one, which is 1, 3, 3, 1. And this would give us the coefficients of the binomial expansion. And remember that this would then equal to, I'll do the whole thing so you can recall. So it's going to be 1 times the first term, 2x to the power of 3. And the second term would be to the power of 0, but I won't write it. So next we would have plus 3, the coefficient that we get from here, plus 3 times, and then the exponent on starts going down, right? Remember, 2x squared times 3 to the 1. And then we would go, okay, this plus 3 again, the coefficient, times 2x to the 1 times 3 squared, and I'm missing one more, plus, and the last coefficient is 1, so I won't write it, plus 1 times, and this would be to the 0, so I don't write it, 3 to the 3. Okay, then we expand this and simplify, and we're going to get that this is going to be equal to 1 times 8x to the 3, so 8x to the 3. Then here we're going to get 4 times 9, that's going to be 36x squared. And then here we're going to get 9 times 3 is 27, times 2, 54, so plus 54x, plus 54x. And then the final term is going to be 27. So now we do the derivative. So what would be the derivative of this? So the derivative would be 3 times 8, that's 24x squared, plus 2 times 36, 72x, plus 54. So this would be the derivative, and this was after expanding the binomial and differentiating it, the polynomial, the resulting polynomial, term by term. Okay, but what if you use the chain rule? So the chain rule is going to make this type of process a lot easier, right? Because if we have that y is equal to 2x plus 3, and this cubed, the derivative would then be equal to, remember, derivative of the outside, so 3 times 2x plus 3 squared times the derivative of the inside, which would simply be 2. So notice that we're going to get that this is equal to, right over here, the derivative would be equal to 6 times, and this one's easier to do because this is just to the power of 2. So we're going to have 4x squared plus 12x plus 9. And then this is going to be equal to 24x squared plus 72x, and 9 times 6, 54. So notice that we arrive to the same answer, but with less operations. Very well, so now we are on example 10.6, which would be the last one on this video. And it says, for each function f of x, find the derivative of f of x. So letter A is f of x is equal to sine squared of x. Now here you have to be careful because recall that this is the same as saying sine of x squared, just like that. So then now we can apply the chain rule. We would say that the derivative of f of x is going to equal, so the outside is x squared, right? So that would be 2 times, leave the inside intact, so 2 times sine of x, but now to the power of 1, because 2 minus 1 is 1, obviously. Then times the derivative of the inside, which is cosine of x. And then, of course, we don't need this parenthesis anymore. We can just, I'm going to put the 1 here just for illustration. And then we can rewrite this simply as 2 times sine of x cosine of x. For B, they have f of x is equal to sine of x squared. So notice that this one is different from the previous one. They are not to be confused because the inside function would now be x squared and the outside function would be sine of x. So obviously the derivative of this would be derivative of the outside, cosine. Cosine of x squared, because we leave the inside intact, cosine of x squared times the derivative of the inside of this, which is going to be 2x, and then it's a good habit to rewrite this as 2x cosine of x squared. For C, we have f of x is equal to e, or Euler's number, to the power of sine of x. So obviously the outside function is Euler's number to the x, and remember that the derivative of Euler's number to the x is Euler's number to the x, so we would just get e to the power of sine of x. But you have an inside function, which is sine of x, and the derivative of that is cosine of x. So we have to multiply it times cosine of x. And some people like to rearrange it as cosine of x times Euler's number to the power of sine of x. Then we have d, and d is f of x is equal to the cubic root of 7 minus 5x and this squared. So whenever you have roots, always change that into exponential form. So how would this be in exponential form? Remember that this is going to be parenthesis 7 minus 5x to what power? Well, this number is the top number because it's the exponent. And then this is the bottom number because it's the root. So this is to the power of 2/3. Then the derivative would be applying the chain rule. Derivative of the outside, so 2/3 times, leave the inside intact or unchanged, so 7 minus 5x to the power of 2/3 minus 1. So that's 2/3 minus 3/3, which is minus 1/3. Minus 1/3. Okay, now times the derivative of the inside, which is just going to be minus 5, negative 5, so negative 5. And then we can rearrange this as negative 10/3 times 7 minus 5x to the negative 1/3. And then you might find this in as minus 10, like this, minus 10 over 3 times 7 minus 5x to the 1/3. And then this can even be rewritten as negative 10 over 3 times the cubic root of 7 minus 5x.